This video overviews some of the grading and scoring comments that I noted to myself in the 2015 AP Statistics exam reading. I'm going to go over three examples, student G, T, and C, and point out some of the common mistakes. So first of all, student G in part A, I, just restates some of the given information essentially. And then notice they start to go off of a confidence interval and start talking about a hypothesis test. And because a two-sided hypothesis test is really equivalent to a confidence interval, this was okay. This was not a deduction. This was just extra information. The problem is really focusing on students' ability to interpret confidence intervals. So if we keep reading, they say the confidence interval is 0.09 to 0.21. They noted that P, which is 0.2, the hypothesized P, the goal, is within the interval. And then they say something about, but it's at the highest end of the range. Now, if they use that to convince you that that's what their decision is, we would have to ding them because a position argument was considered incorrect. If they argued that, well, because 0.2 is at the high end, then it's not likely, that's wrong. But all they said is a fact. It really is true, of course, that 0.2 is at the higher end of the range, but they did not use that as an explanation. So if we keep reading, so far so good, they still haven't really made a decision, but finally they say this does not provide statistical evidence that the program is not working as intended. And the reason is because the intended value falls within the confidence interval. Everything is there that we wanted to see, so this part was given an essentially correct. They had some additional information, but it was not wrong and it did not detract from their good answer. The second part of part A, they first said no, but then they said yes. They said yes, the confidence interval does provide convincing statistical evidence that the program generates a discount at 0.2. That would be equivalent to accepting the null hypothesis, and that is flat wrong. If they say a strong statement like that, that is not true, and that was given an incorrect. If you keep reading, though, as we're supposed to do, they keep some more commentary there, and they said there's some bias that could have occurred, and then they said it is reasonable to assume that the true proportion is 0.2. So if we weren't sure that they were incorrect, we are doubly sure they're incorrect, so they said it twice. So part 2 is considered incorrect. In part B, which is considered section 3 of this problem, they've got some calculations. And then, if that's not clear enough, they said explicitly that if the sample size is 4 times larger, the margin of error will be half the size. That is exactly correct, and that is an explanation that is needed for credit. But notice they never ever said that the margin of error then is explicitly 0.03. They said it would be half the size, but they never said it was 0.3. So this part gets it partially correct. They have to have the right answer and they have to have an explanation or the work. So that's partially correct. And then finally, now that they have created a new interval, and so when you have a margin of error that's half the size, they're going to conclude that the program is likely not working as intended. The smaller margin of error is a more narrow confidence level, and they still haven't really given a reason yet. But they said that it will no longer fall within the confidence interval. And then they list the confidence interval. So then it says it's highly likely the true proportion is in here. That's all true information, extra information. And then they say it again, that interval essentially differs from the intended discount. So they've really given 2 correct explanations for that. And so that's given an E. So if you look at the overall score, so far we have an E, I, P, E, which comes out to be a 2.5. And we can't give half scores. So now we have to look at the problem holistically. Does the 2.5 get rounded up to 3 or does it go down to 2? Well, one thing in their favor is they stated the new interval. From that new interval, it's clear that the margin of error is 0.03. So had they stated that explicitly up here, then this would have been an E and it would have been an automatic 3. So this was rounded up based on that information to a 3. So this student did earn a 3, which is a substantial paper, and I believe that's what we would say. So this paper does seem to be pretty substantial. Not complete, but substantial. Paper T, student T. If you look at the answer to part A, you'll notice they also did a hypothesis test, but this time they wrote something that we cannot overlook. They said the alternative would be less than, and that is not equivalent to a confidence interval. This would have to be a double-sided or a not equal to alternative. And so because of that, this automatically gets a ding. So this is going to get what we call a ding. So it's going to go down 1 notch, either from an E to a P or P to I. We keep reading. The confidence interval? No, the confidence interval does not provide convincing evidence. They have the right answer because the true proportion, 0.2, is found within the confidence interval. That is correct. And therefore, 15% is not statistically significant. So they did get a good answer, the right answer, and the right explanation. But because of this ding, that takes their E that they would have had and marks it downward to a P. So the student got it partially correct on AI. On AII, they mentioned that the interval contains 0.2, and therefore we fail to reject HO. That's essentially saying the right thing. And then they said, while the interval is only, and they of course don't know the confidence level, so we're only C% confident in the approximation. So right now, they have said the right answer. The interval contains 0.2, and therefore we fail to reject that it's 0.2. But they wrote some more, and they said, we can still conclude that there is statistical evidence that the program generates 0.2. They are saying they believe it is 0.2. That's going too far. And so that takes them all the way down to an I. That is an incorrect statement. They're accepting the null hypothesis. They believe that because 0.2 is in there, then there's statistical evidence that it is exactly 0.2. And that's just not right. So far, a student has a P and an I going. If you go to part B, they have a margin of error formula that is correct. You can tell that they had a sample size of 1, and then they had a sample size of 4. And they are using a Z of 0.168. And doing the calculation with a sample size 4 times as big, they do some algebra in there, and they get 0.03. So with the work that they have and with the right answer that they have, that is essentially correct. And then using that 3% margin of error, they do calculate a new interval, and they conclude that the program no longer works because 0.2 is no longer present in the confidence interval. So they had everything. They had the right answer and the right reason, and they calculated a new interval, so they got it essentially correct on both of those. So overall, this student is a P-I-E-E, P-I-E-E. That is, again, a 2.5 score. And so this time we have to think about whether the student should be rounded up or rounded down. A 2 would be developing, 3 would be substantial. And so one of the things that was emphasized in the training is that this part here, part A, Roman numeral II, this is a place we go back to see what the student did. This is a critical question. And they bombed it. They bombed it twice, actually. They said it twice. They really believed that there's evidence. Oh, actually, no, they didn't say it twice. They said it correctly up here, but then they did not say it correctly down here. And that is a pretty major problem. And so because of their lack of a good answer in part 2, and then, of course, they also had a ding in part AI, talking about a confidence or a less than alternative hypothesis, this student's score is going to be rounded down to a 2, which is simply a developing student, and I think that would probably fit. Last student, student C, part AI, they said no because 0.2 is in the interval, and had they stopped right there, that would be full credit. They didn't need to write any more. That's really the probably the shortest answer that you could give that's correct. So they got it right, but they kept writing, so we have to keep reading. Meaning that in some cases, 20% of the bills do in fact receive discounts. Again, no problem. They just said it twice, so they're still essentially correct. Unfortunately, they kept writing. They said, therefore, the program is working. In other words, they believe that P is equal to 0.2, and that is essentially accepting the null hypothesis. And so that is a false statement, and that's actually backwards from what they said up here. So they really just contradicted each other. They didn't really say the right thing in the wrong way. I guess what I'm trying to say is they didn't accept the null when it really was not able to reject. So because this was like an added mistake, this was only given a ding, and so it was taken from an E down to a P. So technically the E that they were earning was dinged down to a P. So the reason this was not given an I is because accepting the null here, or at least saying that there's no evidence it's not true, was not as gregarious as a mistake as in the next section if they would have accepted the null. This was just considered to be an extra statement that was false, and so they get a ding. That was not real clear, but that's the best I can do right now. In II, they said no, and they said because 0.2 is not in the center of the interval. This is a bad thing. When they make an argument about where 0.2 is to justify whether or not you should believe 0.2, reject 0.2 or not, that is what's called a position argument, and that is not what a confidence interval tells you, or does not allow you to say that. So that again was given an incomplete score. So far we have a P and an I for this student. In the next part B, they have the right margin of error, and this was a very common thing that students did. They back solved this using a z critical value of 2, and they solved for n, and then they quadrupled it and plugged it back in, and then did all the algebra and got 0.3. So they've got the work and they've got the right answer, so that's an E. In the final part, they take the new margin of error and they calculate the new interval, and they say, based on the margin of error, the program is not working as intended. That's the right thing to say, because 0.2 is not in the interval. That's the right thing to say. Once again, had they stopped right there, they would have gotten an E on this. But they said that means the discounts are not generated at 0.2 at all. And that would not be true. Just because 0.2 is not in here does not mean that 0.2 could actually be generated. This is going too far, and therefore the E that they would have earned is marked down to a P. So overall, this student earned P-I-E-P, which is a 2. This is a developing student, and that would seem to be appropriate.